Good morning. We are back here. I'm with Jarrett and Chris here in the bunker in Knoxville, and today we're going to talk about the introduction to Watthour testing. And they've messed up and given me the controls to the PowerPoint now, so I can actually move the PowerPoint myself going through this. I've been debating and going back and forth on whether to say anything. I guess you guys have figured out by now that I've chosen to live a Christian lifestyle, and man, the stuff that are on our televisions now is just, and to think that, you know, with all this technology, yeah, there's good parts of it now. Anybody could see it. I can't even imagine young people seeing what's going on and trying to figure out what's going on, and it's terrible. So I'm going to apologize for the presentation today because my head and heart's been other places here lately, but I'm not going to apologize for what I'm about to say. That, you know, we as Christians, we know it all boils down to the heart, and you know, it's a heart issue. And I couldn't watch all of it, of that horrific video. If you know anything about detaining someone, and I do, then you know that as soon as you saw it happening, you knew that's just not right. And I mean, we watched someone, and I know when I was a kid, you know, you thought it was inherently built into you. There were certain jobs that you just had this trust in, doctors, policemen, and to see that happen with someone like that, it's just, it was horrific. And you watched a policeman murder someone, and it was horrible. And there was nothing good about it. And you know, it's the little things, you know, that you see. And he had his hand in his pocket the whole time, just nonchalant, like he's walking in the park. It was horrific. And obviously been praying for the Floyds, and it's horrible. And I also know that, you know, what am I going to put my confidence in? You know, politicians, governments. No, I know who I put mine in. And, you know, I think about Dr. King and what he did, and he stood in the face of dogs and bullets and sticks and fire hoses, and he just stood tall. And I think he talked about Jesus a little bit, as a matter of fact. So, and he used him as an example, who got persecuted worse than him. So I just know watching that, you know, it's a heart issue. And, you know, Jeremiah 17:9 starts out and tells us, you know, the heart is deceitful above all else. It is desperately wicked. Who can understand it? I, the Lord, search the heart. I test the mind, even to give to each man according to his ways, according to the results of his deeds. And watching this stuff is just, I mean, if I'm honest about myself, I don't even know my own heart. I lie to me more than anyone because I know what to tell myself. So how am I going to judge somebody else? I can look at that, and I know what's right and wrong, though. And so I just know that there are people who have spent their whole lives, the very people that this protest is supposed to be for, that now their entire lives are going up in smoke over a TV and things like that. And so as a Christian, you're just sitting there going, wow. And this is where, we always say this, you know, my brothers and sisters say, when things are going great, it's easy to be a Christian. It's when stuff like this happens, and especially when it's more personal, you know, if it's affecting you. And we've got our brothers and sisters out there at Georgia Power and Eversource and Exelon and Minnesota Power, and they're right on ground zero. So if there was ever a time for us to pray for our country and for hearts out there, I mean, now would be the time. So if you'll join me, I'm going to go ahead and pray right now. All right? Heavenly Father, we read in the Old Testament in times of Isaiah, and we read, that's a long time ago. Obviously, we're hearing these same sort of things, global pandemics and rioting and burning down of buildings, and it sounds and looks horrific, especially we see these horrific images on our television set. And Father, this is where we're upset and we're angry, and we know it's what's right and not right. Anyone knows what's right and not right, the Bible says. Believer, non-believer, deep down in your heart, you know what's right. And we see these things, and we're mad. And so as a Christian, we want to bow up. And so I am going to bow up. And here's what I'm going to do, Lord. I'm going to do just what you tell us. I'm going to follow the two greatest commandments. I'm I'm going to love you with all my heart and all my soul and all my mind, and I'm going to love my neighbor as myself. And love is what conquers things. Love is what makes positive change and changes our country forever, like Dr. King did. So, Father, this is where it's tough, and this is where the rubber hits the road. So I pray for all those folks that are in areas that are in turmoil and chaos, our brothers and sisters out there in this industry, and all the people out there. Not just the ones that we personally know out there in these areas, but also those that we don't. And Father, I lift this country up to you. I lift hearts up to you, Father. Get into people's hearts. And let's stop this. And Lord, I just know one thing. The one that was persecuted worst of all was your Son, for who he was and how much he deserved to be persecuted, because he didn't. So, Father, he is the one now that I ask all of these things and say these things according to the will of the one who paid it all, my brother, Jesus Christ. Amen. Thank y'all. Okay, this is the webinar series, as you know. We've got, today is the intro to meter testing. Tuesday is going to be 4-quadrant metering testing. They're going to bring in the smart folks again next week. And then Thursday will be the ANSI C12 update. We've got some engineers coming in to do that. So what we're going to do today is we're going to talk about why do electric meters need to be tested, what tests are run on a meter, what equipment is needed for testing meters. We're going to talk about some inspections out there, some field inspections, things to look for when you're out in the field. And then I'm actually going to go ahead and run a test, and we're going to go ahead and run a phantom load test and a custom load test on a meter. And because obviously we're going to talk about the differences in those two tests, and because those are the two meter tests that you typically do out in the field and in the shop. Okay? So why do we test electric meters? The meter is the cash register. It's the last stop between the builder part and the customer. Meter accuracy must be established to ensure fair billing to the customer and the utility. You know, when I started, everybody, I heard cash register, cash register, cash register. Okay, I heard it's the cash register. Well, I had buddies that tended bar in college, and I can remember them being so mad when they came home at night and the drawer was short. And they had to dig into their pockets and make the drawer square, and they were hot. Well, it wasn't the cash register. It was the stuff going in and out of the cash register, you know. So that's why it's so important also to test the entire site. You have to test the CTs and the PTs because they are the ones putting the money in and out of that cash register drawer, okay, these days. So who establishes the test? ANSI, American National Standard for Electric Meters. So we have the ANSI. And ANSI, some people, I've heard people say, you know, what ANSI says goes, and ANSI isn't enforced, you know, ANSI makes the rules. Well, no, ANSI is actually, they don't enforce the standards, but they provide the guidance and standards. Who actually does the enforcing are our PSCs, our PUCs, our public service commissions, our public utility commissions, the local governments. You know, you can or can't decide, you know, depending on if you want to follow the ANSI guidelines. Most people do follow them in some shape or form, maybe not all of them, part of them, but that's what we use as our guidelines, okay? Then what tests are run on a meter, okay? There are you have what we call in the lab the ANSI meter test or the phantom load test, you've heard it called, okay? Which is the 3 tests that we've talked about before. It's a full load test, a power factor test, and a light load test. And that is where you can see there the differences are. We go with, and we'll talk about it in a minute, whatever is ascertained as being the test amps, we will take those test amps and we will run those full test amps on the full load with a power factor of 1 or unity, no problems. And then we will run a, sorry about that. Good catch, Chris. I just threw my phone to him. Okay, so that was nice. One-handed, sweet. Okay, so then we have the power factor test, which is where we really jack that power factor up. It's 0.5. You remember from Tuesday that is horrific. Huge. You would see a huge angle on your vectors when we were talking about those vectors Tuesday. You'd see a 60-degree angle on your vectors. It would be horrific, and you would have 0.5. So you'd be losing half of your revenue. Okay, when you multiplied voltage times current times that 0.5, then you're cutting it in half, right? So we're going to make it really bad on the power factor. Then on the light load, it is always According to ANSI's guidelines, it is 1/10 of the full load. So if I have, on a transformer rated site, if I have 2.5 amps, which it should say on the face of the meter, we'll look at that in a minute, as my test amps, my full load then, I would take 1/10 of the 2.5 amps and I would get 0.25 amps, or 1/4 of an amp is what I run at light load. That's why it's so slow and takes so long. I'm only running 1/4 of an amp through that meter. Okay? Now the meter test boards, as it says here, they generate the ideal voltage and current to run the meter test, and an electric power standard is used to verify the meter's accuracy. Okay? So let's go through an example of an ANSI meter test, okay, on a meter. So remember we had talked about the nameplate before, and there's a lot of information on that nameplate, and it directly relates to how we're going to test that meter. Okay, you see it's a class 200 meter. The first up in the upper left-hand corner, CL200. That means that meter is rated for 200 amps. It also shows a voltage range there of 120 volts all the way to 480 volts. So that meter can work using any one of those voltages from 120 to 480. Okay? That meter can also be used for a 4-wire Y connection or a 4-wire delta. And we see the form of the meter now on the next line. This is a 16S. Okay? Now if you go over to the right-hand side there, you see that the KH is 21.6. So what we're saying is when we test this meter, we're going to use it's going to be 21.6 watts per pulse, or 21.6 watts per disc rotation. And we'll talk about that again here in just a second. And there we go in that bottom right-hand corner is that TA equals 30 amps. So when it says that, you can look right below that, that then becomes our full load, like we mentioned just a second ago. That now becomes our full load amount. That's what we use. We use 30 amps for full load. So look down there at the bottom on light load. 1/10 of 30 is what? 3. So it's like we said, it's always 1/10. So the light load, we're going to run 3 amps on it. So you can think of it as we're going to run it at a good load for that meter, you know, a nice load, but then we're going to drop down to almost nothing, because there have been cases, and not as much now, but back in the day with the, you know, the old geared meters, that maybe sometimes when you hardly had anything on there, we would get some differences. So they set this up so that we'd run it with a good amount of load on it, hardly any load on there, and then jack up that power factor, and ANSI says bless it and go on. Okay? So what tests are run on a meter? In the field, we do a customer load test using the customer's actual voltage and current. We've done those here in the webinars for you, which is where we using the duck bills and the alligator clips, the duck bills to pick up my current, alligator clips to get my voltage, and I use a pickup up there to count my pulses so I can do a comparison, and I actually use the load at the customer. But if I do a phantom load test, now that's where we have to use a load box, right? Because I'm going to remember we disconnected our CTs, we shunted them, so we weren't getting current from the CTs anymore, we were getting current from the load box. And it supplies the current, and sometimes, and it says impossibly voltage, when you're out there at a substation, testing at a substation, and I know guys are nodding their heads right now, you want to isolate everything. So you will actually open up the voltage switches as well on that test switch, and you will provide the voltage as well. So in that case, you will need a load box that provides not only the current, but the voltage, because I don't want any back feeds and tripping any relays or anything and cause those sirens to go off and make me jump in the truck and want to get out of there quick. So what I do is, in those cases, I open everything and I use a load box that has both current and voltage. Okay? And the phantom load tests are typically based on the ANSI meter test we saw before. How does a meter measure power? So the meter's got 2 stators over here, a voltage stator and a current stator. And remember what we said Tuesday, power equals what? Voltage times current times power factor. Okay? So it has to be able to measure the voltage, it has to be able to measure the current, and then we've talked about the power factor. When we multiply those together, that's where we actually get our watts. Okay? And you recognize this slide from Tuesday. This is where we're talking about, you know, phase and power factor. As we get some power factor involved, and you can see one is leading or lagging the other, that is the big effect on you and I out there in the field, because that changes everything for us. Adding that power factor in there brought into all these vectors and angles, but it's key to us because we're measuring on the back side. Once it goes through that, we provide that power out there on the pole as a utility, you guys do, but then once you turn everything on and the customer gets fired up and it actually goes to the customer, that changes everything. Then we go from VA to watts, and the watts involve the angles and the power factor. Okay? And we talked about this Tuesday, and we'll talk about it again. Power factor represents the ratio of active power, the watts, to the total power of VA in a system. It's equal also to the cosine of a phase angle for a sinusoidal system. So remember, if you think about when we did that power triangle Tuesday, remember we said that it was the angle of theta, the cosine of theta, remember, we said that it was the total here is VA, so you had watts over VA, so it was the adjacent over hypotenuse, and it worked out just like that to where it came out to be the watts over VA. Okay? Also, for you and I, we don't have power triangles on our equipment out there, we have vectors. So when we're looking at those vectors out there, the angle between the voltage and the current vector on the same phase is that angle theta, and they take the cosine of that. But in my pea brain, I've told you all over and over, I keep it simple, keep it simple Sam, is the bigger the angle, the worse the power factor, and the more money I'm losing as a utility company. Okay? Oh, did I hit the right one? Okay, so how does a meter measure power again? Mechanical meters. Remember the old gears and turning the gears, okay? So in that case, the voltage and the current would generate a magnetic field, and then that field would turn those gears, okay? Now the solid state meters, we've gone digital, so now we're using pulses and not rotations of a disc anymore. Before, when that, let's take a transformer rated meter, when that disc would rotate around one time, the old black line on the disc, right? When it would rotate around one time on a transformer rated meter, that represented 1.8 watts, right? Now, when that meter sees 1.8 watts, it pulses instead, okay? That's why we have these pickups now. They can pick up the pulses, okay? So you can see on the left-hand side, the meter, we're going to say the solid-state meter, which has got a microprocessor in it. It receives the voltage and current using those stators, right? It picks them up, and from that, it powers up the display. It has a real-time clock in there because when you get ready to start doing a demand test, right, or you want to know how long someone's used, because we actually bill people on energy, right, which has time involved. So I need to have a clock in there so I can measure my time. Because remember from Tuesday, we had to multiply by that time. You ran it for a day. We multiply by the 24 hours to get our energy because we need kilowatt hours. So you got to have something to measure time, right? So we have a real-time clock is involved in there. And also the communication module for your AMI. Everybody's doing AMI installations now. Or think about it also on the communication. Now you guys can remotely disconnect people. You can talk to the meters, okay? We talked about this some Tuesday. Energy is what we sell, right? It involves that time. That's why you have to have the clock. So you have the electricity. It measures energy in watt hours. Okay, and then of course we convert it. We showed that Tuesday with the math to kilowatt hours, and that's what the actual bills show. But so for test purposes, it says here the meters output a pulse to indicate how much energy has been measured. That's when we use those either magnetic pickups on the communication port, or we're using the flexibles with the rubber band to go around the meters, and we test with that in case it's on the face somewhere and isn't coming out the COM port where I can use a magnet. So the pulse outputs, just like we said on a solid-state meter, a pulse, it can be IR or visible light. It's is emitted to indicate how much energy has been consumed. That's why you can see that mag pickup. That's a magnetic pickup right on that COM port I just talked about. So the light pickup is used by the meter test equipment to make precise accuracy measurements. Okay? So that means every time I see that pulse, my meter says, okay, you've connected my alligator clips on this test switch to pick up my voltage. You've connected the duckbills to pick up my current. So now I can do what we talked about Tuesday. I can do my volts times my current times my power factor. And I can also tell you watts. So I can tell you watts from what I measure. And then I can take what I measured in watts and say, well, you pulsed, so that was supposed to be 1.8. So let's compare those two and see how accurate that meter is. Okay? Now I've got, what is KH? So KH is, it's just a pulse constant, okay? And on a For instance, like we just said, 1.8. 1.8 would be the K sub H on a transformer rated meter, which tells me when I see 1.8 watts, I pulse. Okay? On the mechanical meters, of course, it was a revolution, and we would say revs. So you've heard people say revs before. That's what they're saying. Then the KH on a mechanical meter, 1.8 watts, I get 1 rev of the meter. Okay? And that we saw earlier is on the nameplate here. So for this 16S that we see right here, you can see that the K sub H is 21.6. So when I receive a pulse with my test equipment, I expect to measure 21.6 watts, or pretty darn close to it, for the accuracy of that meter. Okay? So how is the meter test run? So the meter's energy is given as, and here's the next few slides I'm probably going to go through kind of quick, and Mullins is giving me the grin because you know I keep things simple. So here we go. It's the K sub H times the number of meter pulses or disk revolutions. So you can see here, remember we said if it's 21.6 per pulse or rev, and I get 3 pulses or revs, then I have used 64.8 watt hours. Okay? So meter is tested against a power standard. So the standard measures the power same way as the meter, but typically it's 4 to 10 times greater accuracy than that. In other words, you hear about our test equipment, and we say it's 0.05% accurate, or it's 0.02% accurate. Well, for a 0.2% accuracy measured meter, the meter's 0.2% accurate. If my piece of equipment can measure 0.02, I'm 10 times more accurate. The 7 series is 0.02% accurate, so it's 10 times more accurate than the meter. The 3 series is 0.05% accurate, so it's 4 times more accurate. And so we know if you're going to measure something with a piece of whatever it is, it needs to be more accurate than what you're measuring, or you're hitting your head against the wall. So typically those are typical ranges, 4 to 10 times. Okay? Let's see. Okay, and we know that there's a standard within all of the test equipment out there. Sorry, I hit the button. But there's always there's a standard within the piece of equipment, and it compares that standard and that accuracy to what we're seeing from the meter. So how's a meter test run? Guys are smiling. They've ever had to use a detonator switch, we call them, the push button switch there. So what you're doing is, this is back in the day when instead of the test equipment, which it does now, counting the pulses for you with those pickups, you had to use the detonator switch and hit it as that disc came around. And that was an art form. I've seen guys out there that were really good at it. It's amazing. And not me. I'll just tell you up front. These guys have had a lot of practice, and it really is an art form. Okay? And here's where we get in the tall weeds a little bit as far as I'm concerned, but Mullins twisted my arm and made me show these, so I'm going to go ahead. So here we go. So the percent registration equals EM over ES times 100%. So where EM is the energy measured by the meter, and ES is the energy measured by the standard. So if you think about it, we're going to take a standard, which we obviously, you know that we have to always calibrate these standards, and they have to be so comparable to NIST, and so they have to be super accurate. So we have that standard in the equipment. So the standard in the equipment does a measurement and compares to what the meter told me. Just like we said a minute ago, the meter told me that I just should have seen 1.8 watts. Well, the standard then compares it and says, well, let me tell you what I've seen too, and we'll make a comparison of that. Okay? So 100% we never see is perfect, and we know from what other classes we've done here, if it's over 100%, the customer's getting in your pocket a little bit. If it's less than that, you're getting in the customer's pocket a little bit. And here we go. So K sub H equals 0.0001 watt hours per pulse. And the number of standard pulses, that's right, Mullins grin at me, equals, anyway. It goes back to what we said before. I'm just going to go right to the bottom there. The percent registration is what the meter measures compared to what our standard measures times 100. Okay? So in this case, we had 64.75 is what the standard was, and then the meter was 64.8. So like we said before, percent registration is, you're going to compare the 64.8 to the 64.75. You can see in this case, when you do the math there, it comes out to 100.08%. So the customer is getting in their pocket a little bit. Okay? Okay. So we've got equipment required. So we've got the load box, electric power stander, meter socket, lab testing, often use ideal conditions. Yeah, and think about that. If I use a load box, I'm controlling the current. I'm controlling the load that's coming through that meter. So yeah, you can think of it, it is very controlled and it is ideal in that I could make it whatever I want to make it. But when we're out there and then we do the customer load test, that's when it is as a live and takes everything into account what's going on at that customer. All of the problems, which you and I, that's our job, is to find the problems. So then we can see all the problems and everything. All you're going to see with that phantom load test and when you use a board in the shop or in the lab is just the meter. And then you take that meter and you could connect it into a mess, okay? And but you won't see any of that when you test just the meter. That's why field testing is so important, okay? You have benchtop testers like this, which you can pull the meter and put them in here. We have customers that have one of these in every one of their vans, and they've got it strapped in the van, and they walk out and they pull the meter and they stick it in the van in the excuse me, in the test kit. A sip of water here, and then then they let the thing run while they're doing their paperwork. Sorry, seeing that pretty orange just chokes me all up. And I made Jared laugh. That's hard to do. Okay, so so you can see here, you can pull the meter and you can put it in there, and like I said, you can do the work. Or if you know, they're in a lot of theirs is in the Carolinas, so if they have to climb the mountain to go test the meter, they may unstrap it out of the van and go up there, because you can also carry it into the field and use it. As you guys know, all of the stuff that's orange can be used in the field. So then you would carry it up there and pull the meter and put it in there. All right? And since it does do the phantom load test, it has to have a load box. And it does have one. Okay? When you do it in the field, we come into the field and we make our connections that you guys have seen me do here in the bunker, which is you will connect your alligator clips for your voltages at your test switch. You will connect or insert the duct bills in there to pick up your secondary current there at the test switch. And then that way you'll have the secondary voltage, secondary current, which is the same voltage and current that meter is seeing. And then you can see the mag pickup sitting up there where we will pick up the pulses and count them so we can do the test. When we do the phantom load test is, remember when we use those jumpers, the gray on one end, orange on the other end jumpers that we connect to bypass, and because we're going to shunt those CTs, remember, and use a load box. So we have to take the CTs out of the circuit, so we shunt and open up the shunt switches, take the CTs out, and then that's when we got to put those jumpers there, though, to complete the circuit, because we're driving with the duct bills the current. So there's a little bit more of a close-up. You can see our duct bills over there on the left-hand side. For us, it's always in the white, out the black of a current flow. There's a layer of insulation between top and bottom, or as you see there, the white and the black. And there's two wires there so I can get a flow in and out. So, which is key to me because I'm really just inserting myself in the circuit, right? And I'm just getting to see in series. I'm just putting myself in series, my equipment, so that I can see the same current the meter's seeing. Then over on the right is where I'm making my alligator clip connections, which are the typical connections I use for my voltage. Okay? Let's talk about some inspections out there in the field. We said we were going to talk about that today, and we are. These are going to be some typical, let's say you're going to a residential site, and you go out there and you say, all right, there's my transformer at the pole, that's where this home is getting its power from. So I'm going to look up there and I'm going to do an inspection of it. And I'm going to check the pole out, make sure there's no pole problems. Because now is the time before you really get going. I mean, this is all about, remember, I want all y'all getting home safe. So this is all about safety. So do an inspection. You may pick something up and look there and say, you know what, time out. I need to call a line crew and have them come out here. I'm not going to test anything until we get this checked out. So you can look here and you can see it's typically a 9-step process here that we saw, which is really good, that Matt had. So you do the condition of the wiring that's up there. You can check out that primary fuse link. We don't want to see anything hanging out of bail when we walk up there, right? You probably hear from it, but let's say nobody's there at the house, and there's a bail laying open, okay? Then the primary bushings, make sure there's no problems there. Make sure there's not an issue with that lightning arrestor as well. And then check out the transformer tank. You never know. You might see a problem with the actual tank itself. You might see a leak or something, right? And then you also want to check those secondary connections on that side. And you also want to look at your structural connections. You go up there and that transformer's leaning really bad, definitely want to call somebody on that, right? Also, make sure that tank's grounded when you look up there. Make sure it's got a good ground connection. Now, when you actually get there to the home, you've also got the structural connections right there actually at the home. Look at the weather heads. Make sure there's good connections there. Then when you actually get down to where you and I are going to actually start using the equipment, you want to take a look at that meter loop right there. Look for a broken conduit, okay? Make sure there's not a broken meter seal there. There's been some kind of tampering or somebody's been messing with it. Look for broken or cracked glass on that meter as well, right? Or smoked glass, absolutely. And then possible tampering. You know, we're always having to deal with that. And then make sure that there's always adequate grounding, okay, for safety's sake. So you want to do an inspection of it. Like we said, we're going to do an inspection of the base. Make sure about the weatherproof, the knockouts. If you see debris and junk in there, don't give anything a path to track anything. Don't give any, clean everything out. You're there. You know, I love to see these guys when they're out there working, and I see you guys taking ownership of these things. I mean, you clean the things out. You make sure. You might not be the next guy coming behind to test this site, okay? So remove any of that debris. Check out the bulkhead and look and see if there's any burning marks, okay? And don't think that it doesn't happen, okay? The one on the left there, Powermetrix now does, we do field testing for, I don't know if, we said it a lot, but we're out there now doing testing for utility companies. And the one on the left, actually, I just received not long ago from our guy out in the field that was doing some testing. So don't think you won't run across this stuff out there. And then look at the one on the right. They walk among us. So I don't but anyway, you can see where someone has, to keep them from getting cooked or, well, I won't go into all those stories that I've heard. Yeah, not being able to have children and all the other stuff. So then you look on the one on the left. Yeah, if you see anything burnt when you look at anything, man, you men and women back up and say, whoa, whoa, whoa. No, I'm not getting in there at all, okay? And that's just, you can open up the cabinet and see that right there, which is what, we've seen. So, and on the right is an example of seeing one of those leaking transformers out there, okay? Type of field meter test, the customer load, we said that's real world conditions. That's where we're going to use the current coming from the CTs, okay? And we're going to use the potential there at that site as well. So it's real world, it's site conditions. So it tests all the wiring to the CTs, all the wiring to the PTs, all of those connections. It tests the CTs and tests the PTs because they have an effect on what happens to us, right? So we always preach you need to do a site installation test in the field to really know if you're losing money. And that's what this is all about. We're trying to find the leaks in the system. When you're using the water analogy for current and the water flowing through the pipe for electricity, we're looking for the leaks. The phantom load test is the one that you do in the shop with those test boards. That's where you plug the meter in, it tests just the meter, and it runs that full load, power factor, and light load test. Okay? Here's some typical tests. You've got a customer load meter test here, which as you can see, it had pulses expected and pulses actual. So what did it do? The pulses actual is where we counted the pulses with the mag pickup or that flexible pickup with a rubber band. We sat there and counted the pulses, and we counted 10 of those pulses. So every time we counted that pulse, according to what we told the meter was our K sub H, every time that meter pulsed, we should have seen that number of watts, okay? But the pulses expected is where the piece of equipment we're using actually measured voltage times current times power factor, and it came up with watts. And it said, okay, I'm going to take those watts and divide by that K sub H, and I'm going to get the number of pulses that it should have been, okay? So I measured 10 pulses, but according to what I came up with in my number of watts, and I converted it using, let's say, the 1.8, and I come up with the number of pulses that it should have been off my measurement. Remember earlier in there we said measured versus standard, then we made the comparison and we said 100.015, okay? So the customer's coming out a little bit ahead here. Phantom load test. Remember there are 3 tests that comprise the phantom load test. Full load, the power factor, and the light load test, okay? And you can see there, Full load was where we used, we're using 5 amps in this one. Looks like you can see the current there. So we used the 5 amps, and then the power factor turned out to be 0.868. So you can see where we came out as 99.954. If you look at the power factor test, notice the difference in the power factor there. It drops down to almost to about half, right? And then the light load test, you can see there on that light load test that we run 1/10 of whatever the full load was. So you can see there where it has 4.995 for the full load test. It's 0.497 for the light load test. Always a tenth. So now we're going to do a live demonstration. So I'm going to go ahead. I've got a 9S meter here. And what I'm going to do is I'm going to run a customer load test on it. And then I'm going to run a phantom load test on it and show you the two differences, okay? Okay. So I've got my, I'm looking here on the screen here. I just wanted to show you this because, like I've told you guys a bunch here out in the field, from here up is required, right on the screen. When you create a site for us, because we all go by sites at Powermetrix, so we call these installation sites, so we do a site test. So when you're entering and creating a site, above my hand is required. After that, you can enter in a lot more information if you want to, and by that you can sort when you use the free software, the Meter Site Manager software. You can sort by meter form. The next time you want to test that site, you can set it up on a route. So you can add more stuff, but here up is what you have to enter in. And don't forget up in this upper right-hand corner, that's where you put in that K sub T. If you forget to put that in there, the Powermetrix equipment will default to 1 as the K sub T. And when you get 1 as a K sub T, there's a good chance you're going to get your registration jacked up unless you just get lucky and it actually is 1. Okay? So I'm going to pick out a site here that I have in here. I think Jared's trying to test me. I can't see very much. Hope it looks good on camera. Okay, so I've created one here, and what I'm going to do is I'm going to run an integrated site test number 2 because I've created one that's going to run a customer load test and then a phantom load test only, because today we're talking about meters. Okay, so I'm going to hit number 2 here. And you can see here it's going to do a customer load test on the meter, and as we've talked about in previous webinars, that I set it up for 30 seconds or 3 revs. So it's whichever it sees first to complete the test. If I get, if I'm running slow and in 30 seconds I get 2 pulses, then it will complete the test, and I'll have 2 pulses instead of 3 because I hit the 30 seconds first. And then I'm also going to run a phantom load test you can see right here. Okay? I'm going to hit next. So as always with the Powermetrix equipment, it always shows you where to make the connections. So it's telling me right here I need for a, you can see at the top, for a 3-phase 4-wire Y, 3 voltage, 3 current transformer rated site, I should be in my secondary voltages A, B, C, and neutral. And then I should be on my secondary currents, the duct bills, A, B, and C for this service type. All right? Here are the vectors. We always talk about how important the vectors are. And when I'm looking at these vectors right here, I don't see anything that really jumps out at me crazy, right? I don't see a really short, which would be amplitude, which would be a lesser value vector here. They all look pretty consistent on all 3 of the phases. My angles don't look too bad. I can see my power factors over here, 0.93, 0.9. When I see 0.9s, I like those. I don't like to see 0.8s. Because then I'm multiplying by a much smaller number and I'm ending up with less watts and I'm losing more money. So here, I like what I see, so I'm going to go ahead and hit continue. I knew I shouldn't use the field guys one. It's hilarious. And now is that awkward silence where the equipment didn't do what it was supposed to. We'll try it again. Should I tell them the story of what actually happened this morning? Okay. So my equipment, someone had shanghaied my 3 series, and I had to go hunt it down this morning. When I couldn't find it, we used one of these, and we just grabbed it and hooked it up, and clearly we should have tested it more before, because this is not my 3 series. And you can always tell mine because the number's written on the side of the can so I can get it out of my vehicle. So let's try this again. Okay, we've seen that screen. Seen this screen. There we go. Now, for anyone that has worked in the field, which I have for too many years, you're going, yeah, so what? Happens all the time. This is just what it is working in the field. Okay, so now what it's going to do is what we talked about before. It's going to have pulses expected versus pulses actual. So every time, and you can hear it pulse, then this number is going to go up by 1. This is, I'm picking this up off of my mag pickup. It's just counting the pulses, 1, 2, 3. But up here above it, the pulses expected is where it's doing the measurements through the duck bills and the alligator clips, and it's making a comparison of that. It's saying, okay, I measured my watts and created pulses and converted it, but here's where I just counted them. So this is where you're comparing what the meter is telling you and then versus what I actually measure, and I'm comparing the two of them. So the pulses expected is what I measure, the pulses actual is what I just count through the pickup. So it's like I'm taking, here's what the meter's telling me, but I'm going to go ahead and measure myself, and I'm going to compare the two together and see where the equipment says we come from and the standard in that meter and make the comparison there. And when we do that, you can see here, my piece of equipment through the measurements through duck bills and alligator clips said really it should have been 2.999 pulses, but you counted 3. So the comparison of those is 100.032. So we're saying the customer is getting in our pockets just a tiny, tiny bit on this, on the customer load test. And remember, I used everything at the site. All the wiring, the CTs, the connections, everything is taken into account on this. This is an actual site test. The next one, when we do a phantom load test, the phantom load test just tests the meter. I take those CTs out of it, okay? So I'm going to make those connections over here that we've done before, right? I'm going ahead and leave them at the bottom here, and you remember, I'm going to go over this again. The way that you put these jumpers on, because I'm going to shunt, the first thing I'm going to do is shunt my CTs, these short stroke blades, the shunt blades, you've heard me preach this before, the short stroke shunt blades are over here, and then my long swing arm blades are my return blades. And in the returns is where we insert the duck bills. So I come over here onto my shunt blades right here, and I realize that with opening these up, I have an open circuit. If I'm trying to drive through the duck bills, which remember, it's out the black and in the white. So I'm going to drive out here, but when I hit here, over here on A phase, I got an open circuit, so I come over here to the top at A phase, and I make my connection here, okay? Oop, I didn't. Tried to make it more exciting than it really was going to be. All right, so on A phase, I go at the bottom of A phase right here on the return blade and come to the top of the shunt blade over here on A phase, okay? So that now when it hits here, the current, it's going to go through here, and it's going to go into the meter, and it's going to come back out the meter and back through the white and back into the test kit. So now I'm driving from the load box, I'm just driving now through the meter and back. CTs are taken out of it, okay? B phase, C phase, okay? And as we've talked about in previous webinars, there's some more things that have to be checked since I've got a load box involved, right? So with the load box involved, I've got to wait for the guys in the back call it the Christmas tree, like at the drag strips, the lights coming down. So we have to wait for those lights to come down. So what I'm doing is I'm actually waiting to get I have to check out that load box. I'm going to send some signals out there and make sure I've got a good connection. Well, I guess today is the day. Let's try it again. Nope. Hope everyone saw that that wasn't a total catastrophe jump everywhere. All I hit was retry. I've changed this to, and here's where one of the things you can adjust on the far right is the number of pulses. I went ahead and made this 1, 1, and 1 on the pulses because otherwise we'd be here for a long, long time. So I've shortened it down to just 1, 1, and 1. All right, and we all know because that light load is only going to be 0.25 or 1/4 of an amp, that it's going to take longer to do the light load than the other two. So I just went ahead and made them 1, 1, 1 so that we could get through this quicker, so we'd avoid the dead time that Jarrett gives me the stink eye over. So I made it 1, 1, and 1 there. But we know that the light load is always the one that takes forever because you're running 1/10 of the full load. And if you think about it, you know, I mean, what's just happened today? The two little hiccups, and that's just, if you talk to any guy who's been doing this for very long, they have worse than that. But I hope you noticed that just real quick. On the one, I just hit retry, right? When it didn't like it the first time I tried to run the phantom load test, and I've had that happen to me. You know me, I'm just going to be straight up with you guys. The one that I usually see the most problems with is that light load test. You know, when you get on the light load for some reason, you're running such a small amount of current. For some reason to me, it seems like if I had to say across the board, the light load test is normally where you get the most hiccups out there in the field, okay? So you'll just have to rerun it. Now remember, you're going to end up with the box at the end, so I could move that between those 3 tests, and I could retest any one of those 3. So if something screwy came up on just one of them, I would just retest the one. I don't have to retest all of them. I can move that box up or down and just retest. I can do just retest a full load, retest a power factor, or retest a light load test. And then you saw what Chris did right there a second ago is, you know, I know you hate to hear that. I know I do too. You know, reboot it or restart it. But, I mean, you see what happens. It wasn't like, you know, I needed to throw my hard hat or anything. So I just wanted, this is very typical. If you test hundreds and hundreds and hundreds and start getting into thousands of meters, you're going to run into things out there, and we all know that. So all the field guys are nodding their heads. So far, the full load and the power factor look like they fell within what was passable for us, which with the Powermetrix equipment, what you do is you set up what's pass or fail. You give us a range, and we set that up for you because there's a free day of on-site training when you get the equipment. So when we show up out there, we'll ask you, what do you want pass or fail on the meter? What do you want pass or fail on the CTs? And once you set that up the first time, then anytime you run the test, it'll tell you whether it's pass or fail, whether it fell in that range or not. You know, the meters are 0.2, so a lot of people say, yeah, 0.2 is good. So that means if you have 99.8, which is 0.2 less than 100, all the way to 0.2 above 100, which is 100.2, that range is pass. Outside of that is a fail. Okay? I might show up somewhere and they say, no, 2 is. So I said, we use 2 here. Okay? Then that would mean 98 to 100 is pass. Okay? And then that would be, so, and if it fell outside of that, I would get a red number there for my registration, and it would tell me that it did not pass. All right? So you can see there it ran the full load, the power factor, and the light load test. Okay? And all of them are green, which is good for Powermetrix. Red would be bad. So all of them seem to have passed according to what this test kit has been set up for its range, its passing range. So then we've completed the test, okay? Well, I hope you guys got something out of today. I sure do appreciate all you folks tuning in, and also, like I said, these guys really do all the work and everything. But I do appreciate folks telling me that they appreciate what we're doing. You know, I get a lot of emails, you know, thanking me, and man, it's in the midst of all this. I just really consider this a blessing, you know, this technology and everything for us to be able to get this to you guys. So thank you so much for tuning in. Make sure you get your diplomas. You know, hang around with us for the other two so you can get your diploma. And most of all, be anxious about nothing and pray about everything. It's a crazy world out there right now. So all of us just need to be careful, and we know as Christians who to put our faith in. So I just appreciate y'all a lot out there. All right. So if you got any questions or anything, you know, you can contact us. You can call Ray Gore. You can call the professor up and ask him any questions, whether you're standing in the field or you just have a group of guys in the shop and want to ask him a question, or you can be standing there at the pole and he'll go, he may say, FaceTime, and I want to take a look at what you're doing, and so that I can see it live and I can see your connections. Or you can call in here, and we've got backups here in the shop as well. Call me if I'm rolling down the road, not here lately, but if I'm rolling down the road, I'll talk to you as long as, you know, as I'm rolling down the road. If I'm standing in front of a customer, you know, I'm old school, and when I'm standing in front of you, I'm not going to take a call from somebody else. But I'll also help as much as I can. But tap into these resources while you can. Take advantage of us, man, in this situation. And get yourself set up just your own little group. And why not? Set up a private little session with us. And that's what people are doing, and they're working great. So, again, thank you guys so much, and be careful out there, all right?